All right, guys, welcome to vectors. This is in the rectangular coordinate system. So we've already talked about what a vector is, okay, in different forms, like when it's a directed ray in the coordinate plane. But there's other ways to do this, and one of the most common ways, the most popular ways to represent vectors are what we call linear combinations, but with unit vectors I and j. So we're going to talk about some of the same things with vectors, but with respect to if they are written in the rectangular coordinate plane with respect to these unit vectors, okay? So I and j are unit vectors. Vector I is the unit vector whose direction is along the positive x-axis. That's shown in red. So it goes from 0 to 1, a unit vector, 1 unit in length, okay? The vector j is the unit vector whose direction is along the positive y-axis. So that's vector j right there, okay? So I drew a picture of what each of those unit vectors look like individually. When we talk about the components of the vector, A is going to be the horizontal component of the vector. B is going to be the vertical component of the vector. Okay, so the vector AI plus B times J, vector J, is called a linear combination of the vectors I and J. The definition of the magnitude of vector V in a linear combination form is given by double bars times the vector v, or it's almost like the absolute value, but it's double bars vector v is equal to the square root of a squared plus b squared. So here's a couple definitions here of what do we talk about a linear combination. A and b are actually scalars, okay? And we'll get into talking about this now. So we define I and j as a unit vector, okay? So let's talk about if we have this point P, AB in the coordinate plane. The initial point is going to be at 0, 0. The terminal point is going to be at AB. So there's the directed vector. So representing vectors in the rectangular coordinate system, vector V, okay, from 0 to 0 to AB is represented as V equals A times I plus B times vector J. So A and B are numbers, okay, they're scalars. So it's whatever A is times the unit vector over this way and up B times vector J. That's going to give you the combination here. It's almost like that triangular method. A, then B, okay, and there's the combination of AI plus BJ, that point right there. Real numbers A and B are called scalar components, and I've already mentioned that to you. So this is how we can write vectors as linear combinations, okay? So there's the picture I wanted to show you. Now let's look at some examples here in a moment. So, representing vectors in the rectangular form, again, that last board I showed you, I can even bring it back up here quickly. Just remember, when we talked about vectors in component form, it was from 0, 0 out to the head of the vector, okay? This definition here that I'm showing you now is saying, well, what happens if the linear combination, if it doesn't go through the initial point 0, 0? What happens then? How do we write it in that linear combination form? And it's the same definition as when we're not using this linear combination form. You're going to take x2 minus x1 times I plus y2 minus y1 times j. In the other video, we define it as this, almost the same thing, but we would go like this. x2 minus x1, okay, whoops, comma y2 minus y1. That's component form. That's one from the last video. That's when I had two ordered pairs. Okay, but this is saying if we have, again, two ordered pairs and we want it in rectangular form, in linear combination form. Okay? The example I wanted to show you, let's say we have P1 going through 3, 1. It's a vector. Okay? Let's let V be the vector from P1, 3, 1 to the terminal point, negative 2, 5. So we're not going through the origin. The tail is not through the origin. Write vector V in terms of I and J. So if we wanted to do that, we have to write our definition. So there it is. There's your x2 minus x1 times vector I, okay, plus y2 minus y1 times vector j. Okay, so there it is. X2 minus x1 times I plus y2 minus y1. And so there is the vector, the linear combination. Now that would go through starting at the origin and go left 5, up 4, and the vector would shoot off like this going through the origin. Okay? So that's vectors when they're written in as a linear combination with respect to the unit vector I and the unit vector j. A lot of similarities to the video that I previously recorded for you, but this is another way that they represent vectors, and you just have to be aware of that. Okay? If you have any questions or comments, you can type them below. We'll see you next time.